Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, we're starting a new unit today. The new unit is about something called the mole. And the mole is a lot of things. And as you watch the videos coming up in the days to come, I would encourage you to just really pay attention. It's very mathematical, and it's not that difficult of a concept. A mole is like a dozen, except it's a monogamous big number. And you're going to start this thing all out by doing an experiment that is an analogy. And the analogy that it is it's called pennies by weighing and counting. So I have the doc here, right? This is on page 5 of your packet. So this is the experiment that you're going to do on page 5. And it involves you literally weighing a bunch of pennies. And I'm going to walk you through how you can do this right now. So you've got the sheet, you've got a scale, and you've got your pennies. And what you're going to have to do is there's several of these trays. These are called weigh boats. And what you're going to do is you're going to weigh it out. As I read the instruction, it says, determine the average mass of pennies by weighing 25 pennies and do this apparently 3 times. Now, one thing, the reason you've got extra weigh boats is if I put a weigh boat on the scale, I can push 0 because that weighed 2-point-something grams. And then I can start putting the pennies on there, and it will not include the weight of and count out your 25 pennies. Do that 3 times and find out the weight of 25 pennies. The goal is to figure out what's the weight of 1 penny. But you'll do this 3 times with 3 different sets of pennies. Turns out pennies all don't weigh the same amount. It depends on when they were made. They're made of slightly different materials depending on what year the penny was minted. And you're going to do that multiple times. Now, the point of this is that when we learn chemistry, atoms are so small. Remember, atoms are super small, but since they're so small, we don't count them by counting them because they're too small to count. We count them by weighing them. Because ultimately, one thing you're going to do is going to grab 3/4 of your pennies. Kind of the math is this. I'll push 0 on this. I'm just going to grab like all my pennies and weigh them, and you're going to weigh them. This weighs 162 grams. Just randomly grab a big sample, and then I want you to use math to help you figure out how much they weigh. Now, hint, this is a dimensional analysis problem. So let's say that I have 162.32 grams of P for pennies. I can do a railroad track because then in your whole calculations, you're going to figure out what 1 penny weighs. So if you find that 1 penny is equal to 2.3 grams, that's not correct at all. You're going to figure that answer out. Then what you can do is this is a fraction, and you can say 1 penny is 2.3 grams. The pennies cancel, and you could figure out, I didn't do that right. This is how many grams there are. You would say 2.3 grams per 1 penny. The grams cancel, and that would tell you how many pennies there are. And so if this was the correct answer, you could then check to see how many pennies there are. So you can actually, instead of weighing, 187 pennies or whatever that number is, you could actually just weigh them and figure it out. And that's the big point of this experiment. Make sure that in the experiment you are writing out data tables, et cetera, et cetera.